The next unit that we will be beginning is smells. The smells unit is focusing on how different materials in the world smell and why is it that they smell different. So if you smell a cinnamon stick versus a mint leaf, why do they smell different? What is the chemical reason behind that? So you should all have your new smells packet. Please at the top write your name, write your teacher's name, and write the block that you have class at the top. So write your name, teacher's name, and your block. And then flip open to the back of the blue page. So just like all of our packets, on the inside of our all of our packets, we have our learning objectives, and this one's for our smells unit. What we are going to be focusing on in this video is Objective 1, determining the relationship between smells and chemical names. So how do the chemical names of different chemicals and their smells relate to one another? And we will then later on have future lessons where we focus more on chemical formulas and things like that. But we'll start with the chemical names. So let's flip to page 1 for lesson 1. Lesson 1 is called Sniffing Around Molecular Formulas. And so the purpose of this lesson is to explore the connection between chemistry and smells. Okay, between chemistries and smells. And so what you would have when completing the lab for this section, for lesson 1, is we have these vials A through E, and they all have different smells in them. Okay, and so what we would do is, using a wafting technique, which this is wafting, okay, just wafting your hand towards your nose, we are going to smell each vial, A, B, C, D, and E. Each vial has a different name and chemical in it. So for vial A, every vial has a cotton ball, and the cotton balls are soaked in chemicals. And so for vial A, it has L-carvone chemical in the vial, soaked cotton ball, and the molecular formula is C10H14O. And so what you would do is you would take the cap off the vial, you'd waft the smell towards your nose, and record whether the smell is fishy, minty, or sweet. I'm going to give you the results for each vial. Vial A, when smelled minty. Vial B, when smelled, it smelled fishy, not a great smell. Vial C, when we smelled it, it smelled sweet. Vial D, wherever it is, vial D smelled sweet as well. And vial E had, again, a minty smell. So every vial had a different chemical in it. Okay? And so what we want to do is we want to look at these different vials and the smells that they gave us, along with the molecular formula and names for each vial, and pick out some patterns about smells. What made some chemicals smell sweet versus other chemicals smelling minty or fishy? So what elements do all chemicals have in common? Well, all the chemicals above all have carbon and hydrogen within the formula. So they all have hydrogen and carbon. What elements does the fishy formula have that isn't present in the other formulas? So vial B was the fishy formula chemical. And looking at the formula, we said that all of the chemicals have carbon and hydrogen. Our fishy chemical formula has also a nitrogen. No other formula has nitrogen in it, meaning that the element that the fishy formula has that isn't present in the other formulas is nitrogen, or N. Next question asks, what do the sweet chemicals have in common with their formulas? So looking at the two sweet chemicals, here and here, C and D, looking at their formulas, what do they have in common? Well, they have a different number of carbons, and they have a different number of hydrogens, but they both have 2 oxygens. And so sweet chemicals have in common with their formulas that they have 2 oxygens in their formula. Now, what do sweet chemicals have in common with their names? So now looking at the names of the 2 sweet chemicals, pentyl propanoate and isopentyl acetate. Both do have this pentyl in the name. However, that is not always going to be true for all sweet-smelling vials. What is the same and found on both chemical names for C and D, both sweet-smelling vials, is the ending, that the ending for both C and D end in ate. So if this chemical is going to be sweet-smelling, it will have an ending of ate in its name. Now let's compare that to the minty-smelling chemicals. So the minty chemicals, what do they have in common with their formulas? So our minty chemicals are A and E. So here's A and here's E. They both do have 10 carbons, but again, that's not always going to be true. They both have hydrogens, but different number of hydrogens. They do both have 1 oxygen. They do have 1 oxygen. And so minty chemicals have in common that they both have, or all minty chemicals have 1 oxygen in their formula. And then looking at what the minty chemicals have in common with their names. Okay, looking at the names. L-carvone and methone. They both have a different ending compared to the sweet-smelling chemicals. Our minty-smelling chemicals both end in O-N-E. That's pronounced own. Looks like one, but it's pronounced own. So sweet-smelling chemicals have 2 oxygens and their ending of the name ends in ate. While minty chemicals have 1 oxygen and their names end in own. What is the overall relationship between a chemical smell and its name? Well, looking at the sweet smell chemicals and their names, they had an ate ending, while the minty chemicals had an own ending. The overall relationship between smells and names are the endings of the name. Depending on the ending of the name of the chemical, we're able to distinguish the type of smell it will have. If I found a bottle marked methylbutanoate then, methylbutanoate, looking at the ending, it ends in ate. And what other chemical or what smell ends in ate? We have ate here. And so this chemical must smell sweet, because sweet chemicals end in ate. And if methylbutanoate smells sweet, which the following formulas would be the best guess for methylbutanoate, well, looking at what sweet chemicals have in common with their formula, sweet chemicals have 2 oxygens in their formula, which leaves us only with choosing the second chemical formula, C5H10O2. We are going to skip the challenge for today's lesson. But overall, what is hoped to be gotten from this first lesson is that different chemicals have different smells, and depending on the ending of the chemical, the smell will be different. And there's also ways of recognizing different chemicals based on their ending of their formula as well as the ending of their name.